So if you recall, you're going to need this cheat sheet again today. We used this and we worked on different methods of factoring using our special patterns, difference of squares, difference of cubes, sum of cubes, and then this three-term one is mostly review, multiplying to c and adding to b, and then the Xbox method. But then we also, when there's four terms, we figured out how to use the box method. Then we started a little bit of synthetic division in order to factor. Now the next two sections are going to rely quite a bit on synthetic division, but really it's going to be more or less about what can we do to or how can we factor our problems using any of these methods, and when do we identify which method to use. Okay, so to start, we're going to do 5.5, and we're just going to start solving polynomials, which is going to rely heavily on factoring. Okay, when with one learning target, that you can factor polynomials of any number of terms in order to find solutions. Okay, when a factor appears more than one time, it is considered a double root. Okay, it's considered a double root. Okay, or a repeated factor. Okay, all of these are going to work for us. It's just a factor that's been repeated itself. A lot of times you're only going to see it happen twice, so it's a double root, but it is possible to have like triple roots, fourth time roots or whatever. Okay, so we're going to see that today, and so we're going to refer to those as repeated factors or double roots, etc. Okay, let's just start by solving by factoring. Really, we're going to go ahead and use these same process that we've kind of used in the past. If you remember from chapter 4, we often factor, set equal to 0, set the factors equal to 0, all of those things to solve. And that's going to be true here in this section. So let's go ahead and check out number 1. So number 1 here, I'm looking at this and it's set equal to 0. And we want our equation set equal to 0. But after we set it equal to 0, we want to take out the greatest common factor. So this is always our first step. Step 1, set equal to 0. Second step, check for a greatest common factor here. Variable-wise, they do not all have a constant variable, but they each appear to have a common factor of 4. So I'm going to go ahead and divide each term by 4. Okay, 4x to the 4th divided by 4 is just x to the 4th. Negative 40x squared divided by 4 is negative 10x to the second power. And then 36 divided by 4 is 9. Okay, and then that is equal to 0 because 0 divided by 4 is 0. So now I'm looking at this, and even though it has x to the 4th, if you recall, this is in quadratic form. Okay, we have a term, no variable, a variable of 2, and then double that into variable of 4. So we can treat this just like any other quadratic equation. So we've taken out the greatest common factor. Now we're going to ask how many terms are there. Okay, looks like we have 1, 2, 3 terms. Okay, so we have 3 terms. Does my a value equal 1 is the question I need to answer. Okay, if I look at this, it is just x to the 4th. So yes, my a value does equal 1. Yes, so we're just looking for numbers that multiply to the c value and add to the b value. Okay, so we're looking for numbers that multiply to the c value, 9, but add to the b value, negative 10. So that would have to be x squared minus 1 and x squared minus 9. Okay, negative 1 times negative 9 is positive 9. Negative 1 plus negative 9 is negative 10. Okay, next what we have to do is we have to identify whether these two terms can be factored. Remember, that was a big part about what we had done yesterday, or the class before, was we had to see if these factors, even after we factored, if they could be factored again. And in this situation, they can, right? So this one here is 2 terms. Okay, so if we look here, this one here is 2 terms. And we have to check for special patterns. Now it's subtraction, and I'm identifying perfect squares in all of these, right? X squared is a perfect square, 1's a perfect square, x squared again a perfect square, 9 a perfect square. These are all a difference of squares. It's this special pattern. Okay, So this special pattern says a squared minus b squared factors into a plus b times a minus b. So we need to find the root of each of these, right? The root of x squared is x. The root of 1 is 1. So this here is going to factor into x plus 1 times x minus 1. Okay, and then here, x squared, the root of that is x. The root of 9 is 3. So this is going to factor into x plus 3 times x minus 3. Okay, so this whole thing is equal to 0. So just like the zero product property said, if I have some number a times some number b, and its result is 0, that means one of those numbers have to be equal to 0. Well, that's true here. Even though I have 4 terms, or 4 factors, I have 4 numbers being multiplied by each other. And when those numbers are multiplied, I get 0, meaning one of these is going to have to be equal to 0. Okay, so we can set up 4 equations. X plus 1 is 0, meaning x is equal to negative 1. X minus 1 here is 0, meaning x is equal to 1. X plus 3 is 0, meaning x is equal to negative 3. And then x minus 3 here is 0. Minus 3 is 0. That looks wonky, but it's supposed to be minus 3. That means x is equal to 3. Okay, so as I look at this problem, we ended up with 4 answers. Okay, x can be equal to negative 1, it can equal to positive 1, it can be equal to negative 3, and it can equal to positive 3. This is the point of factoring. The point of factoring isn't just to write it in a different method. The point of factoring is to write it in a different method that will allow us to actually solve the equation and allow us to get x values that actually make this set equal to 0. Okay, A can be done very, very similarly. Okay, go ahead and try it on your own and check it with me when you're done right now. So I'm looking at this one. This one does have a greatest common factor, so I'm going to go ahead and take that out. It looks like I can divide a 2 and an x out, so I'm going to have to take a 2x out like this. 2x divided by 2, or 2x cubed divided by 2x is x squared, minus 6x, and then 9. Okay, so then here, this cannot be factored, but this number can be. It can be factored. Well, I have 3 terms. I have 3 terms, and my a value is 1. That means I'm looking for numbers that multiply to c and add to b. Multiply to c and add to b. The numbers that multiply to positive 9 and add to negative 6 are negative 3 and negative 3. So I get 2x times x minus 3 times x minus 3. That's equal to 0. Well, this means 2x times x minus 3 squared is equal to 0, which means I have 2 factors here. Okay, 2x is equal to 0, so that means x is equal to 0. Okay, and then x minus 3 can be equal to 0, and that means x is equal to 3. So this one I only got like 2 answers really, even though I had 3 factors. Okay, and as you can see right here, this x minus 3 is a repeated factor. Specifically, it ended up being a double root because it appeared twice. Okay, this is a repeated factor. And specifically, it's a double root because it happened twice. It would be a triple root if it happened 3 times. Okay, so now let's try to flash back to the previous section where we had this word problem. We mostly used a calculator to solve it, but we did see that, you know, if it crosses at x equals 2, my graph crosses at x equals 2, that means that x minus 2 is a factor because positive 2 is the value that's going to make this equal to 0. Okay, so if we have identified where a graph crosses the x-axis, that is going to be a factor. Or if I know what a factor is, that is going to be where it crosses the x-axis. They go back and forth. Okay, so again, to repeat, if I know an x value that crosses the x-axis, that means the factor x minus that number is a factor. Or if I know the factor, the value that makes that factor 0 is going to be where it crosses the x-axis, and they go both directions. Okay, we're going to use that to find the zeros of a polynomial. Okay, so we need to remember that when I have a factor x minus k and it's raised to an odd power, so like x minus x, so an example of that would be just like x minus 3 or x minus 3 to a third power. I guess this is not review. This is something new. Okay, if I just have it and it's raised to an odd power here, that means it's going to cross right through the graph at that exactly one time. Okay, but if we have a factor, let's say like x plus 2 and it's raised to an even power, okay, what that means, it's going to go and it's going to approach the x-axis. It's just going to touch it, and then it's going to come right back down the direction it came from. We're going to see that here in a moment. Okay, so what we want to do is we want to find the zeros of these functions, okay, and we are going to do that by factoring. Okay, then we're going to have to remember some stuff from 5.1, I believe, about graphs, but we'll see that here in a moment. Okay, so here, let's go ahead and factor this. If we factor this, this can help us see where it's going to cross on the x-axis, as we just talked about. Okay, and so looks like we can take a -2 out of each of these. So let's go ahead and take a -2 out. We get x to the 4th plus 16x squared. No, minus 16x squared. Okay, I have totally screwed this up. Let's start over. Okay, -2, taking that out, and we get x to the 4th. And then positive 16 divided by -2 is -8, x squared. And then -32 divided by -2 is positive 16. Okay, so when I'm looking at this here, I can factor. Okay, we have 3 terms, and my a value is 1. Following my flow chart, I need to know that I just look for numbers that multiply to c and add to b. Okay, these numbers happen to be -4 and -4. Okay. Okay, and then it turns out that these each factor. Okay, these each factor because it's a difference of squares. So following my flowchart, I have 2 terms. So I need to look for special patterns, and this is a perfect square minus another perfect square. A perfect square minus another perfect square. So this is going to factor into x plus 2, the root of x squared and the root of 4 times x minus 2. Okay, and this is going to factor into the same thing also. All I'm doing is following my flowchart. Well, we have a bunch of repeated factors. Okay, so this is going to factor into -2 times x plus 2 squared times x minus 2 squared. Okay, so all I did is I rewrote my factors up here above so I can go ahead and check out the graph. Now, there's some things that we need to know about this. We know that the degree is even. The degree is even, meaning it's going to either both shoot up at the ends, the end behavior is both going to shoot up, or they're both going to shoot down at the ends based on the end behavior. Okay, the leading coefficient is negative, so we know it's going to be like opening down, and it's going to be shooting downward. Okay, so what does this mean? If I look at this, I know that this is according to what we've talked about. This is my factor, x plus 2. So the value that makes this negative, or makes this 0, is going to be where it crosses or touches the x-axis. The x value that makes this factor 0 is -2. So I know my graph is going to touch or cross at -2. What's the x value that makes this 0? Well, it's +2. So that means my graph is going to cross or touch the x-axis at +2. Okay, so now we just have to figure out, does my graph touch the x-axis there, or does it cross through it? Well, these factors are raised to an even power. Since they're raised to an even power, it's just going to touch the x-axis. If they were raised to an odd power, it would go right through. Okay, so I know the end behavior is telling me my graph is going to be shooting downward at the ends. Okay, and so it's just going to come on up here, and then since that's an even factor, it's just going to touch. Yeah, okay. Okay, well, we know it's going to shoot down and then come back up. it has to come back up, so otherwise it's never going to get to the positive 2. So it's going to look something like this. Okay? Just in general, this is it's just a sketch. So we have an idea looking at the function and the factors, we have an idea of what's going on. Now, one thing that we need to know, though, is this. We actually do know what this value is. We know what that y value is, okay? Because when x is 0, these two terms are 0, leaving just this value here, and that would be on the y-axis. So this is actually my y-intercept. So that's a y value of negative 32. Okay. So another important part is when you factor, it helps us see and understand some things about the graph. Okay. So again, I know it was opening downward because my leading coefficient was negative. I know both ends are shooting down together because I have an even degree. I know it touches the x-axis at negative 2 because I have a factor of x plus 2. And it's raised to an even power, so it only touches once. I know it's going to go through 0, negative 32 because my y-intercept is negative 32. And then it's going to hit the x-axis again and then come back down at x equals 2 because I have a factor of x minus 2. And it's even, so it's just going to touch it and go back down. Okay, what I would do is I would try B on your own. Go ahead and sketch it to the best of your ability. Okay, and I would start sketching it by factoring. Okay, so I'm assuming that you have all already tried this and you are seeing how you did. Okay, I'm going to start by factoring this. Okay, there's no greatest common factor. Okay, so I can just go ahead and identify that there's 3 terms. My a value is 1. So I'm just looking for numbers that multiply to 81 and add to negative 18. Okay, that is going to be negative 9 and negative 9. Okay. Then I'm looking at each of these and I know that these can be factored because this is a perfect square and this is a perfect square and I'm subtracting. This is a difference of squares. So it's going to factor into x plus 3 times x minus 3. This is going to factor into x plus 3 times x minus 3. Okay, meaning this factors into x plus 3 squared times x minus 3 squared. Okay, so what does this mean? This means that my graph here, knowing this, is going to cross the x-axis at negative 3. Okay, and by cross, I actually should say it's just going to touch it because the degree of this repeated factor is even. Okay, same thing here. I know it's going to cross at or touch at positive 3 because it's raised to an even degree. Okay, I know this graph is both going to open up in the same direction because my degree is even and my leading coefficient is positive. So it's going to go ahead and it's going to go down here. It's going to go up. Then it's going to go down here. It's going to go back up. And it at some point has to hit the y-axis here. And we specifically know that that's going to be at the value of 81 because that is my y-intercept. Okay. So it's just kind of nice to know how the graphs and the factors relate to each other and how we can actually really truly understand a lot about the graphs just by looking at the equation and identifying some key features, which I know we've worked on in 5.1. So this is a good connection back to that. Okay. Let's go ahead and try to factor some things using the rational root theorem. The rational root theorem means essentially saying is if I have some function and it's in polynomial form, okay, so it's some polynomial that we've dealt with of any number of terms. That's why that it's a sub n and x to the nth power. It's any number of terms. So it could have 5 terms, 6 terms, 7 terms, 8 terms, 4, 3, 2, it doesn't matter. Okay, and the coefficients are integer. Every rational root, okay, every rational root, so fractional root, of f of x is equal to 0 has the following form. Okay, that means it's always going to be the factor of the constant term, okay, the constant term divided by a factor of the first leading coefficient. Okay, so if I take the constant term and divide it by the leading coefficient, that is that is a possible factor of our problem, okay? So where this is going to be very, very important is this is going to help us get started on factoring these problems, okay? So let's go ahead and see what that looks like in example 3. So let's just go through our process. I think that's going to be consistent for everybody. That's going to help everybody. Okay. The first thing we want to check for, based on our factoring flowchart here, is I want to check for the greatest common factor. Okay. So I'm looking at 1, negative 8, 11, and 20. To me, there's no greatest common factor. Okay. So then I have to ask my questions: how many terms are there? Well, there's 1, 2, 3, 4. There's 4 terms. Okay. When there's 4 terms, I want to ask is the second value, or b over a, equal to d over c. Negative 8 over 1. Is that the same as 20 over 11? The answer to that is no. Okay, the answer to that is no. That means we have to use synthetic division to factor. Okay, so what I'm going to teach you today is how to use synthetic division method of factoring, okay, when all other options are exhausted. Okay, so now after today's lesson, you're going to have every single method of factoring ready to go. Okay, so I'm going to show you how to use synthetic division to factor. Okay, and you're only going to use synthetic division to factor when all other methods fail. Okay, so when all of these other previous methods that we spent 5.4 on are just not usable, they're not applicable. So this is our last resort. Okay. So we can't use any other method. We need to start by finding possible roots. Okay, we need to find possible roots, and you're going to find those possible roots by, using the rational root theorem. You're going to take your constant term, p, and you're going to divide it by your factor of your leading coefficient, q. Okay, so for us, all numbers, okay, so if we take p over q, okay, that's going to be equal to 20, okay, because 20 divided by 1, okay? So all numbers that are factors of 20 are possible roots, okay? What does that mean? Our possible roots are 20, but not just 20, positive and negative 20. What's another number that divides evenly into 20? 5. Okay, so plus or minus 5. Okay, another number, plus or minus 4, plus or minus 10, plus or minus 2, plus or minus 1. Okay, so just to get started, we have 2, 4, 6, 8, 10, 12. We have 12 different numbers that could possibly be roots, and there's only going to be so many that we can actually use. So back in the day, when I was in school, what we would have to do is we would have to check every single one of these values to see if they make this equal to 0. Because if it makes it equal to 0, we already know from previous sections, if it makes it 0, that means it's a factor. Okay? If it makes it 0, that makes it a factor. But there's a nice shortcut for us because we have the technology for that. If you recall from several sections, but including today's, if it crosses the x-axis, that means that value is a root. If that value is a root, we now know the factor. For example, if we know it crosses at x equals negative 2, we now know we have a factor at x plus 2. So we're going to use that fact. Okay? We're going to use that fact on the graphing calculator. Okay. So it's pretty straightforward. But the first thing I think you should all do is make sure your window is in a standard view. So we're going to hit zoom. And if you go down to number 6, it's gonna put us in a nice standard place to look at. Okay? Negative 10 to positive 10. Okay. So what we're going to do here is then, okay, we're going to hit y equals, and we're just going to type this equation in. So we're going to get x to the third minus 8x squared plus 11x plus 20. Okay, so we just typed our equation in, and now we can hit graph. Okay, it looks like we have 3 roots. Okay, it looks like at -1, at +4 maybe, and then at +5 also maybe. Okay, so what we can do is we can pick one of these. Okay, well, -1, 4, and 5, those are all possible roots. So that's a pretty good indicator that those are going to work. Okay, so I am pretty sure that x equals -1 is a root. Okay, and this was found on our graph. Okay, now x equals -1 is a root. So since x equals -1 is a root, I believe that x plus 1 is a factor. Okay, so I'm just giving everybody some time to kind of absorb everything that I've said. We found x equals -1 on the graph. That's where we believe it crossed the x-axis. It's a possible root for us, so I believe it to be a root. Since x minus 1 is a root, I believe that x plus 1 is a factor. Okay, it's basically just the opposite here. Like I would add 1 to each side to set it equal to 0. Okay, so that means x plus 1 is the factor, or -1 is the value that makes this 0. Okay, if I plugged in -1. Okay, so now what does that mean? That means I can divide this polynomial by this polynomial. Okay, so how can I divide that? Well, if you recall, for the same reason here, we went ahead and said this was a root, so that's my factor, so we divided it out. We can just use synthetic division here. Okay, we divided x to the 4th plus 3x cubed minus x minus 3 by x plus 3, and we got a result, and then we could factor it more. That's exactly what we're going to do today. Okay, that was just from 5.4 on page 4. Okay. All right. So what we can do we can use synthetic division to divide x to the 3rd minus 8x squared plus 11x plus 20 by x plus 1. Okay. Now, these steps that I'm giving you, feel free to use those when you're working on your own. But in general, they're not necessarily required for you to do the work. Okay, so I want you to be able to do this independently. Okay, so let's go ahead and do this. So if I'm going to divide this by this, I'm going to set -1 out here because that's the root. Okay, and then I just put the coefficients in here. So 1, -8, 11, and 20. Okay, so I'm going to drop my 1, and then I'm going to go -1 times 1 is -1. And put that there, and then I'm going to add here to get -9. Then I'm going to go -1 times -9 is +9. I'm going to put that there. Then I'm going to add 11 and 9 is 20. -1 times 20 is -20. That's 0. This is what I would consider very good news. I want everybody to think personally to themselves, why is this such great news? Well, hopefully we have a remainder of 0. What does a remainder of 0 mean? A remainder of 0 means x plus 1 is a factor. Okay, that's great. That means that we've done everything correctly. We don't have a remainder. That means it is a factor. So that means I've already factored this out. This is my remainder. This is my constant. This is my x. This is my x squared term. It just works right up the ladder. Okay, so now I have this x plus 1 times x squared minus 9x plus 20. Okay, that means we kind of have a fourth step now, and that means continue until completely factored. Okay. All right, so that means this is already factored, but this can be factored further. So we're going to refer back to our flowchart. Okay. I have 3 terms. My a value is 1. We're just looking for numbers that multiply to c and add to b. So I'm looking for numbers that multiply to negative 9 and add to 20. So that means numbers that multiply to 20 and add to negative 9, that's negative 4 and positive 5. And then once it's completely factored, you just solve. So x plus 1 is 0, meaning x equals negative 1. X minus 4 is 0. This should be negative 5. It's a typo. This should be negative 5. So x minus 4 is 0, meaning x is equal to 5. Or, geez, I'm way off now. 4. And then x minus 5 is equal to 0, which means x is equal to 5. Okay, so we got 3 answers, right? And all of these values are going to, if you plug them in, are going to make it equal to 0. So now one thing I'm going to give you a giant warning, but also it can be helpful to you all, is it is no coincidence, folks, that we have answers of negative 1 and it crosses at negative 1, answer of 4 crosses at 4, and answer of 5 and it crosses at 5. That's no coincidence. That's very much intentional, and frankly, that's just how it works. What I'm going to tell you is I will not accept any work, okay, of you just looking at the graph and giving me those 3 factors, okay? One, our learning target is to factor in order to solve. Furthermore, this method does not always work, because what if we have decimal answers, okay? I'm not going to be able to tell if the graph crosses at 4.8, for example. So I need synthetic division to solve problems like that. Furthermore, okay, what if it has a complex solution, such as, if you recall from chapter 4, I, like 5i or 6i? You're not going to be able to see that on the graph. So I'm requiring you to do this amount of work to find your answers, okay? What you do need to use the calculator for, though, is to find your possible roots to get yourself started. Okay. All right, folks. So, this is the process, okay? And this is exactly what we're going to work on for this section and the next section, okay? So, what I want you to do is move on to C, work through the flow chart, figure out your roots, use your division, and solve. Okay, I want you to go ahead and try that on your own and check it with me when you're done right now. Okay, so I'm looking at C, and there's no greatest common factor. Okay, so there's 4 terms, and I want to see how I need to factor to solve this. Is B over A equal to D over C? 1 over 1 equal to negative 24 over negative 14? No, so I have to use synthetic division. Okay, so what are my possible roots? Well, last term divided by first term. You know, my possible roots, P over Q, is negative 24. That means I could have negative 24, positive or negative 12, positive or negative 8, positive or negative 6, positive or negative 4, positive or negative 3, positive or negative 2, positive or negative 1. I have a lot of different factors. And I don't want to guess and check by plugging these in, figuring out which ones make them 0. I just want to check the graph. I want to see on the graph if I have any possible factors here. Okay, so I'm going to go to y equals. Okay, I'm going to go to y equals, and I'm going to type this equation in. So I'm going to go x to the third plus x squared minus 14x minus 24, and I'm going to graph it. I wonder if I hit something wrong here. Yes, if you can see here, I have a 2 x's here, so let's go ahead and delete one of those. Okay, so it looks like I have 3 different possible roots, and I want to pick one that looks pretty accurate. Like, it looks like to me, I'm most confident in this one here, that's where it's crossed the x-axis, so that's the one I'm going to pick. And it looks to be 1, 2, 3, 4. It looks like x equals 4. Okay, so I think x equals 4 is a root, meaning I believe that x minus 4 is a factor. Okay, so I can go ahead and divide that out. Okay, so since I believe x equals 4 is my root, I'm going to divide 4, or x minus 4 from this here. So I get 1, 1, negative 14, negative 24. Okay, and then I would divide. I'm going to drop my 1. 4 times 1 is 4, and I bring that up here. And then this would be 5. 4 times 5 is 20. I'm going to put that here. And I'm going to get 6. 4 times 6 is 24. That's 0. And this is, again, very good news. Right? It's very good news because my remainder is 0. That means that x minus 4 is a factor. There's my remainder, my constant, my x, and my x squared term. Okay, so then now I can move on to just continuing to factor. So I get x minus 4 times x squared plus 5x plus 6. Okay, and so then this is already factored, but I need to check to factor this more. All right, and so to be able to do that, I have 3 terms. There's no greatest common factor. I have 3 terms. My a value is 1, so I'm just looking for numbers that multiply to c and add to b. Multiply to c and add to b. That's going to be 3 and 2. So x minus 4 times x plus 3 times x plus 2 is equal to 0. And then lastly, I can solve. X minus 4 is 0. That means x is equal to 4. X plus 3 is 0. That means x can be negative 3. And then lastly, x plus 2 is 0, meaning x is equal to negative 2. Okay. So those are my answers, right? Because each factor can be equal to 0, making the whole thing 0. And that's how these problems are done. This process is critically important. Moving on to the next section, which is going to be about the fundamental theorem of algebra. Okay. So let's move on to the last little bit, and then we are done. All right, so sometimes we don't get nice, neat answers like 5, 7, negative 8, negative 2. Sometimes they're going to be irrational numbers. So that has us at the irrational root, or irrational conjugates theorem. Okay, we've actually dealt with conjugates in the past. Okay, so we want to let f be a polynomial function with rational coefficients, and we want a and b to be rational numbers, but such that the square root of b is irrational. What that's saying is if a plus b, the square root of b is a 0, then automatically a minus the square root of b is also going to be a 0. Okay, so what we want to do is we want to write a polynomial function f of least degree that has rational coefficients. Okay, least degree means the lowest degree possible, and has a leading coefficient of 1. Okay, we have the zeros of 3 and 2 plus the square root of 5. All right, so we have this function. It's going to be named f. We know it has a 0 of 3. Since it has a 0 of 3, that means it has a factor of x minus 3. Since it has a 0 of 2 plus the square root of 5, that means it has a factor of x minus 2 plus the square root of 5. For the same reason, this irrational conjugate root theorem, if it has 2 plus the square root of 5, it's going to have one that's going to be 2 minus the square root of 5. So I can rewrite this factor almost, but instead it's going to be x minus 2 minus the square root of 5. Okay, and so this is kind of our first step, okay? And from here we just have to simplify the best we can. We're going to go x minus 3, and then we're going to get x minus 2 minus the square root of 5. Okay, I'm just distributing this negative. For the same reason, I'll distribute this negative here. Okay, and so then at this point, all I have to do is multiply to the best of my ability. So I'm going to go ahead and multiply the two more complex ones together. So we have 3 terms by 3 terms. So let's go ahead and do that. X minus 2 minus the square root of 5. X minus 2 plus the square root of 5. Okay, so x times x is x squared. X times negative 2, negative 2x. X times negative square root of x is negative x square root of 5. Negative 2 times x is negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times negative square root of 5 is positive 2 square roots of 5. All right, so x times positive square root of 5 is positive x times the square root of 5. Positive 5 times negative 2 is negative 2 square roots of 5. Positive square root of 5 times negative square root of 5 is negative 5, right? Square root of 5 times square root of 5, square root of 25, square root of 25 is 5. Okay, here's the thing that's very, very awesome about when you're doing this work. Negative 2 times the square root of 5, positive 2 times the square root of 5 are going to cancel each other out. The positive x times the square root of 5 and negative x times the square root of 5, those are going to cancel each other out. So we really are just left with these 5 cells. Okay, so we are left with x minus 3 times x squared, negative 4x, and then 4 and negative 5 is negative 1. Okay, so this here all simplified into x squared minus 4x minus 1, because these parts here and then these parts here were like terms that could be combined, and all the other parts just canceled out completely. Okay, and then lastly, all I have to do is now multiply these two by each other. So just a lot of the box method. It is going to require a little bit of work here and understanding what is and is not an opposite. X times x is x cubed. X times negative 4x is negative 4x squared. X times negative 1 is negative x. Negative 3 times x squared is negative 3x squared. Negative 3 times negative 4 is positive 12x. Negative 3 times negative 1 is positive 3. Okay, this one I have like terms here and here. All right, so this all is x cubed, negative 7x squared, 11x, and 3. Okay, so this is a function here that has 0, 2 plus the square root of 5, 2 minus the square root of 5 as its answers when it's set equal to 0. And I think this is a good example of, because if we were to look at this one here for the previous examples, I kind of went on the lecture about like you can't just look at the factors every single time and get your answers, and this is a great example of that, because if I were to type this into the calculator, okay, as you can see here, it crosses very clearly at 3, and that's why we have the 3. But it crosses at these weird oddball values here and here. And this problem is factorable. Okay, it's factorable, and we can get solutions from it. But it had weird oddball solutions, right? It had 2 plus the square root of 5 and 2 minus the square root of 5 as its answers. And that's why you can't just take values off of the graph and plug them in. That's why we have to have this process. Okay, so that's how you can write or use the conjugate irrational conjugates theorem to go ahead and get yourself a polynomial written out. Okay, so why doesn't everybody try letter D on their own, and then that will be it for the section. So I'm assuming that you've already tried D on your own and you would like to see it now. Okay, so we're writing a polynomial named G with a least degree that has rational coefficients and a leading coefficient of 1. Okay, so this thing's name is G, so G of x is going to be equal to, and we have a 0 of 4, which means we have a factor of x minus 4. Okay, we have a 0 of 1 minus the square root of 3, which means we have a factor of 1 minus, or x minus 1 minus the square root of 3. Okay, and then using the conjugate roots theorem, or the irrational conjugates theorem, okay, we now know that if x minus 1 minus the square root of 3, x minus 1 plus the square root of 3 is also going to be 1. Okay, so now let's simplify by distributing these negatives and just getting them into the simplest form possible. X minus 1 plus the square root of 3, x minus 1 minus the square root of 3. Okay, and then we're going to multiply these parts together. And this is probably the most complicated part of the problem. Okay, we have 3 terms by 3 terms, so we need a 3 by 3. Okay, we're going to go x minus 1 plus the square root of 3, x minus 1 minus the square root of 3. X times x is x squared. X times negative 1, negative x. X times positive square root of 3 is x times positive square root of 3. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. Negative 1 times negatives, or the positive square root of 3 is negative square root of 3. X times negative square root of 3 is negative x square roots of 3. Negative 3 times negative, or negative square root of 3 times negative 1 is positive square root of 3. Negative square root of 3 times positive square root of 3 is negative 3. Okay. Positive square root of 3 and negative square root of 3 cancel each other out. Positive x times the square root of 3 and negative x times the square root of 3 cancel each other out. And now we have like terms here and here, so we can combine those. So we get x squared minus 2x minus 2. Okay, so this times this is equal to this, x squared minus 2x minus 2. And then lastly, all I have to do is multiply these two parts together. X minus 4, x squared minus 2x minus 2. X times x is x cubed. X times negative 2x is negative 2x squared. X times negative 2 is negative 2x. X squared times negative 4 is negative 4x squared. Negative 4 times negative 2x is 8 positive 8x. Negative 4 times negative 2 is positive 8. I have plenty of like terms here. I have like terms here, and I have like terms here. So we get g of x is equal to x cubed, negative 4x squared and negative 2x squared. That's negative 6x squared. 8x and negative 2x is 6x. and then 8. And again, this is a polynomial that is factorable and has 3 solutions, but they're just more complicated solutions. And so, yeah, so we wouldn't be able to just rip that right off the graph. Okay. All right, that's the section. Okay, biggest thing you need to take away is the synthetic division factoring. That is example 3, I believe. Yes, it's example 3 and C. So make sure you have those ready to go because we're going to be doing that moving forward. Otherwise, move on to the homework, and I'll see you back for Chapter 5, Section 6.